Okay, let's do problem 244. It is about a hot air balloon that is rising vertically upward with a constant velocity of 5 meters per second. So the balloon itself is moving like that, and a sandbag is released from here, and it is 40 meters above the ground. So that's 40 meters, and it is released. Even if it is released from rest relative to the balloon, it is actually moving with 5 meters per second. So the sandbag also has the same velocity as the balloon when it is released. So we can say that the initial velocity of the sandbag is also 5 meters per second. So the problem says after the sandbag is released, it is in free fall. So this is a free fall problem. And compute the position and velocity of the sandbag at 0.25 and 1 second after its release. So first, just draw a simple diagram like this. So the sandbag is going to go up like that, and then eventually it's going to come down. And so just write the quantities that are given. So you can write known quantities. For example, the initial velocity is given, so that's v0y is equal to 5 meters per second. The other quantity that is given is the initial coordinate, which is y0, and y0 is equal to 40 meters. What else? Actually, we need to compute the position and velocity of the sandbag at 0.25 seconds. So let's write t equal to 0.25 seconds. That's the given information. Based on this, we need to figure out the position and velocity. So position is y minus y0. So that's the displacement, vertical displacement, and the velocity. So what we need to do is that because the acceleration is constant, it is a free fall. So we know the acceleration is negative 9.8 meters per second squared. We should be able to use the equations for free fall. So if I write those equations, let me write the first equation was Vy equal to V0y minus GT. Usually it is V0y plus AY times T. So AY in this case is actually negative G, and that's why we have to write this way. The second equation we have is y minus y0 is equal to v0y t minus 1/2 gt squared. That's the second equation. And the third equation was vy squared minus v0y squared equal to negative 2g y minus y0. So y is slightly smaller, y minus y0. Okay, so these are the three equations that we can use to solve this problem, and we need to pick one at a time which equation fits for the given problem. So this is free fall. So these are the equations for free fall. So let's do the first problem, first part, which is A. Compute the position and velocity of the sandbag at 0.25. So we need to use t equal to 0.25 and calculate the position. Again, the position is either here in the third equation or here. So that's the coordinate, okay? And we need to figure out what y is. So because the time is given, we can certainly use the second equation. Because the third equation we don't know what Vy is, and that's why if we knew the initial velocity and final velocity, then we could use the third equation also. But the second equation has everything. We know the initial velocity and we know the time, so we should be able to calculate the y minus y0. So let me rewrite that. Y minus y0 is equal to v0y t minus 1/2 gt squared. Let me put all the values. That's 5 meters per second times t 0.25 seconds minus 1/2. G is 9.8 meters per second squared, and let me make it slightly smaller, and times t squared, so it's 0.25 seconds squared. So this is 5 times a quarter, so 1.25. The second cancel with the second, so meters. Minus, this is 4.9 times 0.25 squared. So this one you can use a calculator. I used the calculator. It gives 0.30625 meters. Okay. Don't worry about the significant figures. If you write a couple of decimal places, a couple of digits after the decimal place, should be fine. So if you subtract this 0.30 from this, you get 0.944 meters. Okay, so that's y minus y0. That's the delta y right there. Okay, so the coordinate itself will be 40 meters plus that delta. So y will be equal to y0 plus 0.94. Let's drop this, just write 94 meters, and that's equal to 40 plus 94, so 40.94 meters. So the coordinate of the position of the sandbag at this time is 40.94. So let's calculate at t equal to 1 second. Okay, 1.0 seconds. You can again put, instead of writing 0.25 there, 0.25 there, just replace that with 1. So I get y minus y0 equal to 5 times 1 minus 9.8 divided by 2 gives you 4.9 times 1 squared. So that means 1 squared is 1, so you get 0.1 meters. So y is equal to 40.1 meters. Okay, so that's what we have. And let me make it slightly smaller. Let me put it there. Okay. That's part A. Okay. We can do part B, which is how many seconds after its release does the bag strike the ground. So we need to calculate the time of flight. So time to go from here to top and then all the way to the bottom. Okay, so the time, again, pick one of these equations. You could use this or the second or the third one. The first one and second one have the time information, so we can use one of them. But the first one, we don't know the velocity. So this velocity is not known, the final velocity. So we have to use the second one. So I can do part, so this is A. Let me do part B here. In part B, I can use y minus y0 equal to v0 yt minus 1/2 gt squared. So it's the same equation, but now for the total time of flight, I have to calculate the I have to use the total displacement. What is the total y displacement? Again, doesn't matter the trajectory. It only depends on the initial height and final height. So basically the displacement is negative 40 meters. Why? Because y0 is 40, so y0 is 40, but y is 0, so 0 minus 40 gives you negative 40. Anything that starts at a higher point ends up at a lower point, then the displacement will be negative. Okay, so negative 40 equal to v0y is the initial, so 5 meters per second times t, and t is what we need to figure out, plus 1/2 gt squared. So 1/2 g is 4.9 meter per second squared times t squared. Okay, so that's what you have. Now you have a square term there, and then to the power 1 and no power. So that means it's a quadratic equation, and you can, I'm sorry, this is a negative. Okay, I wrote plus there. So just rearrange this to make it look like ax squared plus bx plus c equal to 0 type of equation. So bring everything to the other side, to the left hand side, and I can write 4.9 t squared minus 5t minus 40, because 40 is already on this side, so it doesn't change the sign. So that's what I have. And I'm not writing the unit at this point because this looks much cleaner this way. So this is a quadratic equation. To solve the quadratic equation, just recall the equation, the solution. So t would be minus b plus minus 4ac divided by 2. I'm sorry, what did I do? Square root of b squared minus 4ac divided by 2a. So that's the formula. Let me rewrite this. Minus b plus minus square root of b squared minus 4ac divided by 2a. So that's what the equation is. So so t is equal to minus b, so that means this becomes plus or minus square root of b squared, which is negative 5 squared, which is 25, minus 4, a is 4.9, times c is negative 40. So this negative 40 and this negative sign, they give you positive, so that means divided by 2a, so 2 times 4.9, which is 9.8. So if you use a calculator to calculate this this part right here, you will get this plus 5 plus or minus 28.44 divided by 9.8. And if you look at the plus or minus, you have a choice. If you use negative, then you're going to get the negative time, which basically means past, and you don't want to use the negative time, just use the positive. So that means 28 plus 5 divided by 9.8. And if you use a calculator, you get 3.41 seconds. So it took 3.41 seconds to start from here and then go all the way up there and then go down. So that's the total time of flight. Okay, that's how much time it took. Now in part C, C is with what magnitude of the velocity does it strike the ground. So we need to calculate the magnitude of the velocity. So I wrote A there, B there. Now I'm going to write C here. For magnitude of the velocity is, again, go back to these equations. Which one of these equations will allow you to calculate the final velocity? So we need to calculate the velocity there. So the final velocity, you can certainly use the first equation, final velocity equal to initial velocity minus gt. You can also use the last equation, which is final velocity squared minus initial velocity squared equal to negative 2g y minus y0. You have everything there. So let me use the first one. So vy equal to what? And I can write vy equal to v0y minus gt equal to 5 meter per second minus 9.8 meter per second squared times t, and t you just calculated, which is 3.41 second. Okay, equal to, if you use a calculator, this is gonna give you 5 minus 33. So let me just write the final result, minus 28.44 meter per second. So we got the final velocity, and it is negative because it's going downward. So that's why you know, the sign comes out to be negative. Okay, so that's C. In part D, they ask you to calculate what is the greatest height above the ground that the sandbag reaches. So we need to calculate the height. So basically, you're looking at a trajectory to go all the way to the top right there. Okay. Now, anytime you calculate the maximum height, always remember that at the maximum height, the velocity is 0. Okay, so that's what we need to use. The velocity is 0 at the maximum height. So for maximum height, Vy is equal to 0. So if Vy is 0, you can calculate the time for the time it takes to go from this point to the maximum height, and then use that to calculate the y minus y0. But if you use the third equation, it does not even involve time. So you have final velocity, which is 0, initial velocity and the only unknown is the y minus y0. So it makes sense to use that. So Vy squared minus V0y squared equal to negative 2g y minus y0. So we just said that Vy squared is 0, so we don't need to even look at that. So basically I have minus V0y squared equal to minus 2g y minus y0. Negative and negative will cancel, so y minus y0 is equal to V0y squared divided by 2g. So that's going to give you the maximum height. This is still a displacement, and once you get the get this number, which is 25 divided by 19.6 meters, and if you use a calculator, you will get, let me see, you will get 1.275 meters, or you can say 1.28. So that's y minus y0. Okay, so y will be 40 plus this, so that means it's 41.28 meters. So it actually went up to 41. So that's a 41. It started from 40, went to 41.28 meters. Okay, so this is pretty much done. The last part, which is part E, you just need to sketch the graphs. Let me quickly sketch the graphs here. So E, it says, what is the acceleration versus t? So you already saw that the acceleration is actually acceleration due to gravity, and it is not changing with time. It's still the constant. So if acceleration is there in the y-axis and t in the x-axis, the acceleration has to be somewhere there, which is 9.8 meter per second squared. Okay, and it's negative. So basically you get something like that. That's the curve. If you do velocity versus t, velocity is upward, so positive, but it is slowing down. So it goes down, the slope becomes negative, and when it gets there, the velocity is 0, and then when it goes down, the velocity becomes negative. So if you do velocity here and t there, then it starts from 5 meters per second, the velocity starts to go down and becomes 0 at the maximum height, and then keeps going down with the same rate, and the slope of this line is the acceleration due to gravity. That's the acceleration, so it's what it is now. So at 3.41 seconds, which is the bottom, it's going to have negative 28.44 velocity, so somewhere there. Okay, I can't fit it in the graph here, but that's what it is. Now the last one is y versus t, and that's also easy to do. Initially with time, y is increasing but slowing down, so it goes like this, but then it comes back and then starts to speed up, and that's the type of y versus t graph. Okay, so there are a lot of problems like this, and just practice, do as many as you can. Okay, all right.